Do you know a metal called nickel? It's a core material that modern industry simply cannot function without, used in batteries, stainless steel, and a wide range of specialized alloys. Yet when nickel was first discovered, it was widely misunderstood as a cursed and extremely dangerous metal. In fact, even the name nickel itself was associated with the devil. So how did nickel, now an essential material in modern society, come to earn such a frightening reputation, a metal that once made people tremble with fear? Today, we're going to uncover the fascinating story behind nickel, a metal that once inspired fear but has since become indispensable to human life. Please don't forget to subscribe. Now let's begin. During the Middle Ages, miners in Germany's Erzgebirge region came across a reddish-colored ore. Naturally, they assumed it was copper. In reality, however, the mineral was nickelite, a compound of nickel and arsenic with the chemical formula nickel arsenide. Because its appearance so closely resembled copper ore, the confusion was entirely understandable. If the story had ended with the simple realization that this was not copper, there would have been no problem at all. The real danger began when miners attempted to smelt nickelite at high temperatures, treating it just as they would a copper ore. As this process took place, the arsenic in the ore reacted with oxygen and formed arsenic trioxide, which is an extremely toxic compound. This gas is so lethal that ingestion of only about 70 to 180 milligrams can be fatal for an adult. Even when it did not cause immediate death, long-term exposure was known to lead to skin cancer, lung cancer, bladder cancer, and liver cancer, and it is classified by the International Agency for Research on Cancer as a Group 1 carcinogen. The problem was that this gas was colorless and odorless, so the workers had no way of knowing it was even being released. So how do you think people at the time made sense of what was happening? An ore that looked exactly like copper produced no copper whatsoever. Instead, people began to die for reasons no one could explain. Under those circumstances, this mineral could only become an object of fear. As a result, miners came to believe that the devil had stolen the copper and left behind only a curse. They combined the German word for copper, Kupfer, with nickel, a term referring to a malicious spirit believed to live in mines and deceive or harm miners, and began calling this ore Kupfernickel, which literally means the devil's copper. And yet, despite giving it such a name, they still believed it contained copper. This misconception persisted well into the 18th century. It was finally resolved in 1751 by the Swedish chemist Axel Fredrik Cronstedt. Cronstedt himself initially conducted multiple experiments in an attempt to extract copper from Kupfernickel. However, contrary to his expectations, he obtained an entirely different metal, silvery white rather than red. By carefully examining its metallic luster, hardness, electrical conductivity, and chemical behavior, he realized that this substance was a previously unknown metallic element. He then removed the word Kupfer, meaning copper, from the original name Kupfernickel and gave the new metal the name nickel. In this way, nickel was formally introduced to the world. Even so, Cronstedt himself was unaware of the true nature of the toxic gases generated during nickel processing. Only by taking such risks was the true identity of nickel finally revealed. If it was discovered at such great risk, it must have found practical use somewhere. So where did nickel first find a practical application? The turning point for its widespread use came in the mid-19th century. This shift began with the development of cupronickel alloys made by combining nickel and copper. On the periodic table, nickel is element 28 and copper is element 29, which places them next to each other. Because their chemical properties are similar, the two metals mix evenly and form a uniform alloy. However, when they are combined, the reddish color of copper disappears and the metal takes on a bright silvery white appearance. That is why the alloy is sometimes referred to as white copper. Beyond its appearance, cupronickel also stands out for its exceptional strength and resistance to corrosion. These combined properties made coinage the most natural and widespread application of cupronickel. In particular, in the United States, the 5-cent coin came to be known as the nickel, a name derived from its nickel content. Although 10-cent, 25-cent, and 50-cent coins also contain nickel, these coins are clad with a copper-nickel alloy on the surface, which means their overall nickel content is relatively low. By contrast, the 5-cent coin is made of cupronickel containing 75% copper and 25% nickel, which is why it was given the specific name nickel. Using nickel in coinage is common in many countries. Canada, however, took the use of nickel even further. Until the early 1980s, Canadian coins were made from 99.9% pure nickel. Later, as prices rose and manufacturing costs increased, they were replaced by coins made of steel coated with nickel. If the price of nickel continues to rise in the future, there may come a day when people begin searching for Canadian coins minted before the 1980s. Following the development of copper-nickel, an entirely new alloy emerged in the early 20th century, driving the use of nickel to unprecedented levels. This alloy was rust-resistant steel known as stainless steel. Among all metals, iron has been the most extensively used throughout the development of human civilization. However, when used in its pure form, iron is highly vulnerable to corrosion and is not as strong as one might expect. To overcome these limitations, nickel, chromium, and other elements were added to iron to prevent corrosion and greatly improve its strength, leading to the creation of stainless steel. Today, stainless steel has become so essential that it's difficult to imagine modern life without it. In fact, about 60 to 70% of global nickel production is used to manufacture stainless steel. The development of copper, nickel, and stainless steel drove nickel demand to rise at an unprecedented pace. To meet this enormous demand, engineers and metallurgists developed mass production processes in their own ways. As this industrial expansion continued, the hazards of arsenic oxide released during nickel smelting became increasingly apparent, prompting the gradual adoption of safer smelting and refining technologies. By the late 19th century, commercial nickel smelting had become firmly established on an industrial scale. Despite being burdened with such a fearsome reputation, nickel was rapidly embraced by industry and became one of the first metals to be mass-produced and widely used by humanity. This alone speaks to how indispensable the material truly was. The image of nickel as the devil's metal, however, proved difficult to shake. Although advances in smelting technology greatly reduced cases of arsenic poisoning, refining nickel still relied on the extensive use of hazardous chemicals such as sulfuric acid, chlorine, and ammonia. This led to a saying at smelting sites that nickel was the devil of acids, reflecting how dangerous and difficult the metal was considered to be. As the 20th century began, the arsenic hazards associated with nickelite eventually led to the abandonment of nickelite as a source of nickel. Instead, oxide ores and sulfide ores became the primary raw materials. Even so, strong acids such as sulfuric acid and a wide range of chemical agents are still used in the nickel smelting process. Modern smelters, however, differ greatly from those of the past. They carefully manage hazardous byproducts such as gases released during smelting and spent solutions, improving safety through thorough purification and recycling processes. As modern society developed, nickel began to be used in an ever wider range of applications. One of the most important of these is nickel plating. Because nickel resists corrosion so effectively, it's widely used as a coating material to protect other metals. However, nickel is also known to cause skin allergies, which is why nickel-free plating is standard for items such as accessories that come into direct contact with the skin. That said, nickel is often used as an intermediate plating layer during manufacturing, so people with sensitive skin are strongly encouraged to check whether a product is genuinely nickel-free. This is why product descriptions for items like accessories often emphasize nickel-free plating. In recent years, nickel has become increasingly valuable as a cornerstone of lithium-ion battery technology. Nickel is a major component of battery cathode materials, and when combined with lithium, it significantly boosts energy density, enabling the production of high-capacity batteries. For this reason, nickel plays a critical role in the electric vehicle battery industry. Beyond this, nickel is also used in superalloys that must withstand extremely high temperatures, such as those found in engines and turbines. In short, nickel's applications are so diverse that they extend far beyond what this brief video can capture. Today we explored nickel, a metal that was once called the devil's metal, but has since become a core material of modern industry. Isn't it fascinating that a metal which once brought suffering to people has become a pillar supporting human civilization? And that wraps up today's story. But there's always more science waiting to be discovered in our everyday lives. Until next time, stay curious. I'm Dr. Sai Vera.